Then let's look at the next example. That is example 13. And for example 13, you can see that the question first asks you to draw 3 coordinates on the polar coordinate plane. So you have to mark where is the point A, point B, and point C. Then you have to mark it. And I think actually it's not difficult to mark it, because for this point 460 degree, I mean point A, 460 degree, you just need to read from the polar axis first. 4 is here, and then for 60 degrees, that is read here for the polar angle, and that's why the 4 just follow the circle, and then up to 60 degree, then I mark a cross here and mark the point A, and then write down the polar coordinates of point A, 460 degrees, just like this. And then for point B and C, you also need to mark it on the figure. So for point B, it is 1, so I read from here 1, and then 150 degree, that means up to here, and then here is the point B, and then I have to write down the polar coordinates of this point B as well. And lastly, for point C, 3 here, and then up to the polar angle 240 degree, that means here, so I mark the cross here, and here is the point C. And then the coordinates I may write once again here. That's all for part A. And then for part B, part 1, you are asked to find, okay, you are asked to find, also explain AOC lie on the straight line or not. And then for the straight line, you need to find and you need to clarify their angle. That means now you are asked to think about that for this C, okay, AOC, that means this is a straight line or not. And then for this line, how to check they are straight line or not? You have to think about their angle and check if angle AOC equals to 180 degrees or not. Okay, if this is equals to 180 degrees, then they form a straight line. If not, then they are not. And that's why maybe I try to go to the next line to let you to look at the solution about part B. You can see that here we can calculate the angle AOC by using the reflex angle XOC and then minus the angle XOA. And then why we have to do in this way, you can see that because now I told you that we need to find, okay, the angle here. And then how to find this angle? I may use the polar angle in the polar coordinate. And then I just need to use this angle XOC, but it should be the reflex angle XOC. Use the big angle and then minus the smaller angle, that means this part. Then you are calculating the size of angle AOC. So for this angle, easy, you can read the polar angle of C, that is 240, and then minus the polar angle of A, that is 60 degrees. Then you can get the answer. It is really equal to 180 degrees. And that's why AOC lie on a straight line. Okay, this is the explanation for part B, part 1. And next is that for part B, part 2, you are also asked to find the distance between A and C. And then for A and C here, once you know that they are forming a straight line, then you know that for the distance between A and C, that means I can use the distance, AC. I can use OA plus OC. And why I have to use OA plus OC? Because I know the length of OA by just reading the radius vector of A, that is 4. And then OC, I know the length of OC by just reading the radius vector of C, and the radius vector of C, that is 3. And that's why the length of AC is equal to 7. And that's why this is the solution. Okay, this is the solution of part B. That's why it's 7 units. And I think for this example, you can learn some more by using the polar coordinate to calculate about some angles or some lengths. So you may study about this example again to try to understand it. And for the rest of the slides, I think you can read it by yourself. I may not explain here because for the rest of the slide, it's just the comparison between the rectangular coordinate system and the polar coordinate system. You can read by yourself. Okay, and then try your best to finish the homework that I had assigned to you. Okay, see you next week.